Hey guys, it's Miss Johnson and I'm here to bring you the rest of our Unit 2 Notes 3 video talking about solving systems of equations algebraically, specifically using the elimination method today. Tomorrow we'll talk about the substitution method, or in the next lesson we'll be talking about substitution, but today we're just going to get through elimination. So we talked last video about how we can't solve two equations with two variables. We need to make it one equation with one variable. So here are some steps of how we do that. The first thing that we want to do is we want to put both equations in standard form. And that's what I talked about when we have the x's lined up, the y's lined up, the equal signs lined up, and the constants lined up. So if you don't remember standard form, it looks like this. Ax plus by equals c. After we have them both in standard form, we need to make sure that we have opposite coefficients. That's what we're trying to find there, is opposite coefficients. So if it has opposite coefficients already, great. If not, then we're going to have to do a little work, which means we're going to have to multiply by something. We did that a little bit at the end of the last video where we had to multiply by a -1, and we may have to do that to both equations this time. There may be some numbers involved, but however we can get opposite coefficients for either x or y is what we need to do next. Then we need to add the two equations together, just like we did in the other one. Combine them, combine the two equations, and one of the variables should cancel out. Solve for the variable that's left. These are all steps that we did yesterday, or in the last video. Substitute that value into one of the equations and solve for the other variable. Okay. So again, remember that when you're watching a lesson video, if you need to pause because the notes went too fast and you didn't have time to write them down, go ahead and pause it and we'll move on to the next example. Number 1, I have x plus 2y is equal to 10 and x plus y is equal to 6. So I'm already in standard form for both. X over x, y over y, equal sign over equal sign, 10 over 6, constant over constant. But my coefficients are not opposites. This coefficient is a 1, that's a 1. This is a 2, that's a 1. So I'm going to work with these x's because they're at least the same number, and that helps me. And I'm going to go ahead and multiply these by -1. I chose the bottom equation for no particular reason, just so that I had one that was negative. So my top equation stays the same. Bottom equation turns into -1x plus 1y, oops, sorry, minus 1y equals -6. Don't forget to distribute. Minus 1y is equal to -6. And then we combine them. And when we do that, the x terms drop out because -1 and 1 is 0. And then 2 minus 1 is 1. And 10 minus 6 is 4. So my y variable is equal to 4. Because dividing by 1 won't change my answer. Then I plug it back into one of the originals. I'll just use the top one. I have x plus 2 times 4 is equal to 10. That's x plus 8 is equal to 10. Subtract the 8, and I get x equals 2. So my solution here is x is 2, y is 4, and that is my system. In number 2, I have 4x plus 2y is equal to 8, and I have 3x plus y is equal to 8. So right now, at least the first step is to check if your variables are lined up. X is lined up, Y is lined up, equal signs, constants, everything's in the right place, which is great. Then I look at my coefficients. Here I have a 4 and a 3. Ooh, that's not so great to work with. Here I have a 2 and a 1. That's not horrible, but they're still not the same number. So I can very easily multiply this bottom equation by a 2 so that I get to 2y. But I also need it to be negative, so I'm going to multiply by -2, which makes it -2y, because then it's an opposite with this positive 2y, and they'll cancel out. So distribute that across. I have the top equation stays the same. Bottom equation, -6x minus 2y is equal to -16. And then I'm ready to combine because now my y terms go away. Then I have 4x minus 6x, which is -2x. And I have 8 minus 16, which is -8. Divide by -2. and I have x is equal to positive 4. Plugging that back into one of the originals, I'll just pick the top one. 4 times 4 plus 2y is equal to 8. That's 16 plus 2y is equal to 8. And then subtracting the 16, let's scroll this down a little bit, I'd have 2y is equal to negative 8, and divide by 2, I get y equals negative 4. So my solution here is positive 4, negative 4. Let's try the next one. Solve using elimination. 2x minus 3y is equal to 11. 10x plus 10y is equal to 30. So x's, y's, equal signs, constants lined up. They're both in standard form. Great. Coefficients, 2 and 10, not the same number. 3 and 10, not the same number. So I need to figure out how to make one of these opposites of the other. I can very easily take 2 and multiply it by 5 to get to 10, but I need it to be a negative 10, so I'm going to multiply by negative 5. So if I multiply by negative 5, remember that it goes all the way across. I end up with negative 10x plus 15y is equal to negative 55. And then 10x plus 10y is equal to 30. Now I'm ready to combine. My x terms drop out. I have, oh gosh, 25y is equal to negative 25. Divide by 25, and I get y is equal to negative 1. Plugging that back into one of the originals, if I just pick the top one, 2x minus 3 times negative 1 equals 11. That's 2x plus 3 is equal to 11. Just multiplying the negative 3 times the negative 1. Subtract your 3. 2x equals 8. Divide by 2. X equals 4. All right, so, oh, and I guess I didn't really mean to box that. My solution here would be 4 comma negative 1. That's what I needed to box. There we go. All right. All right, so let's move on to number 4. In number 4, my coefficients, well, my constants are all lined up. My variables are lined up, so that's a good start. X, Y's, equal signs, constants. And then I need to check my variables. So I have a 5 and a 12. It's not pretty. And I have a negative 4 and a negative 12. That's better because at least I can multiply to get to negative 12. So that's what I'm going to do. They're both negative. I need one to be positive. I'm going to take this top equation and I'm going to multiply by a negative 3 because negative 3 times negative 4 is going to give me positive 12. So I have a negative 15x plus 12y is equal to negative 90. Bottom equation stays the same. So these are going to drop out. I have negative 3x is equal to 6. Negative 90 and 96 is 6. So then I divide by negative 3. And I get x equals negative 2. Plugging that back in. 5 times negative 2. Oops, not negative 12. Negative 2, there we go, minus 4y is equal to 30. That's negative 10 minus 4y. Adding 10, I have negative 4y is equal to 40. That's a y. And dividing by negative 4, I get y is equal to negative 10. So my solution there, negative 2, negative 10. Okay, a couple more like this, then we're going to check out some word problems. So number 5, check your variables, m's and n's this time. Little different variable, but that's okay. We can still use them. So m's lined up, n's lined up, constants lined up, equal signs lined up. We're all good to go. Check the coefficients. 10 and 3, not pretty. 5 and 3, also not pretty. So this is a system where I'm going to have to multiply both options. I need to get to a least common multiple, and I need to multiply, so I'm going to have to multiply by both. or multiply both equations. I'm going to choose to work with the ends because the 3 and the 5 are a little bit smaller, and I kind of like picking that. It wouldn't matter if you picked the m's first. Doesn't matter. I'm just choosing the ends. I also like that one is already positive and one's already negative, so I don't have to worry about the signs, switching the signs. So this top equation, I'm going to multiply by 3. And this bottom equation, I'm going to multiply by 5. Because that's going to give me a 15n and a negative 15n, and then I'm good. So let's check out what these new equations look like. 3 times 10 is 30. So 30m plus 15n is equal to 15. And then in the bottom, 15m minus 15n is equal to 120 is what I get when I do 5 times 24. So now I can combine. And the n's go away, which is what I hoped for. 30 and 15 makes 45, so 45m is equal to 135. And then divide by 45, and I get m equals 3. Plugging that back into one of the originals, I have 10 times 3 plus 5n equals 5. That's 30 plus 5n equals 5. Subtract your 30. You have 5n equals negative 25, and dividing gives me n equals negative 5. So we go in alphabetical order when we write these, so my solution is going to look like 3, negative 5. All right, one more of this type and then a couple of word problems and we're set to go. Number 6, 14x plus 21y is equal to 14. 3x minus 9y is equal to negative 51. So x's, y's, equal signs constants, I'm good. They're already in standard form, so that's helpful. Then I look at the coefficients. 14 and 3, yuck. There's no way to multiply 3 to get to 14. And 21 and 9, also yuck. You can't multiply 9 to get to 21. So I got to multiply both. Again, I'm going to pick the y's only because I have a positive and a negative, and I like that I don't have to worry about switching the signs. The easiest way to do this, you can think about least common multiples, but I think the easiest way to do this is to just switch the numbers. So I'm just going to multiply this top equation by 9 and multiply this bottom equation by 21. Again, I can figure out what the least common multiple is of 21 and 9, but you're using a calculator, so you might as well just use those numbers, and even though you're going to get some big results, stick with your calculator and let it help you. I distribute here. 9 times 14 is 126. So 126x. 9 times 21 is 189. 189y. And 9 times 14 again is 126. In the bottom, 21 times all of those. That's a 63x minus 189y. This is a biggie. Negative 1,071. Add them up. So the y's are going to go away. 126 and 63 is 189. So 189y, and then 126 and negative 1,071 is negative 945. Again, use your calculator to help you to get these results. That's totally fine. Divide by the 189, divide by the 189, and you've got y is equal to 5. Then plugging that back in, 14x plus 21 times 5 is equal to 14. That's 14x. Oh, hello. This is an x, not a y. Just kidding. Sorry. X equals 5. X equals 5. Get rid of this. Caught it. At least I caught it. That's good. Sorry, let's try that again. 14 times 5, there we go, plus 21y is equal to 14. That is 70 plus 21y is equal to 14. Subtract the 70, that's 21y is equal to negative 56. And I get kind of a funny decimal here. I'm going to divide by 21. I get a decimal answer, which is possible. You can have decimals in graphs. It's just kind of an ugly answer, but I get negative 2 2/3. On your calculator, it might have looked like negative 2.6 repeating. You can write it in fraction form or in decimal form with the repetin over the top. Either way is fine, doesn't really matter. But if I write out my solution, I have an x value of 5 and a y value of negative 2 2/3. All right, let's check out some word problems. Number 7, it says Dante spent $11.25 on 3 new and 4 old comic books. Samantha spent $15.75 on 10 old and 3 new. Write a system, figure out how much each comic book cost. I'm not going to read all of these word problems out to you, just like I didn't in Unit 1. If you need to pause the video so that you can take time to read through them, go ahead and do that. I need to write out some equations. So I know I'm looking at new and old comic books. I'm going to say that X is my new and Y is my old price. Then I have an equation for Dante. Dante has, well, I guess nope, Dante is first. So Dante has 3 new, so that's 3X, and 4 old, that's 4Y, for $11.25. Samantha has, and be careful with Samantha's because she lists her old ones first and her new ones second. So hers are 3 new plus 10 old for $15.75. So I have x's, y's, constants, equal signs lined up. I need to take this top one and I need to multiply it by a -1. You could do the top or the bottom, it doesn't matter. But that's going to give me -3's to solve this. So I've got my system, now I'm solving it. So negative 3x plus 4y, oops, minus 4y, goodness. There we go, is equal to negative 1125. So I'm done with that equation. And now I'm looking at this system and solving it. Your y terms are going to drop out. I'm sorry, your x terms are going to drop out. Your y terms are going to be 6y is equal to $4.50. Divide by the 6, and you get y is equal to 75 cents. All right, so there's one. Now I got to go back to one of the originals and figure out what the other one is. If I plug it back into just the top one, I have 3x plus 4 times 75 cents is equal to the 1125. That's 3x plus 3, 4 times 75 cents is 3, is equal to 1125. Subtract your 3. You have 3x is equal to 825, and divide by 3. X is equal to 275. So if I were to write this out as a solution, I know that the new comic books are $2.75. Don't forget your dollar sign. And the old comic books are 75 cents. And there you have it. 2 more word problems, then we're done with lesson 3. Amy is walking in a straight path, modeled by that equation. Kendra is walking in a straight path at the same time, modeled by that equation. At what point will the 2 girls be in the same place? All right, beauty here is we're given the equations. Okay, problem, they're not both in standard form. So if I line them up, I have 3y is equal to 6x plus 6. Now I want to know when they're going to be in the same place, which means I'm trying to solve it. Okay, but if I take a look at this, I have a plus sign with an equal sign and an equal sign with a plus sign, and that's not going to help me. So I need to fix one of these. I'm going to move this 6x back so that I have them both in standard form. So if I do that, the top equation's fine. It's already in standard form. So negative 2x plus y is equal to 3. Bottom equation is going to be negative 6x plus 3y is equal to 6. So there, now they're both in standard form. Equal signs and constants are lined up. I'm good to go. I don't have opposite coefficients, but I can easily multiply this top one by negative 3 to get a positive 6 and cancel out my x's. When I do that, I end up with positive 6x minus 3y is equal to negative 9. Now I'm done with that equation. I'm looking at these two, and I'm going to add them up. Here's what happens. Negative 6x and 6x cancels. 3y and negative 3y also cancels. Uh-oh, now I'm left with nothing, or in other words, 0, on the left-hand side. Both variables dropped out. On the right-hand side, 6 minus 9 is negative 3. Now we have to ask ourselves, does 0 equal negative 3? Is that true or false? That is a false statement. That will never be true, which means there is no solution. Okay, so the true answer to this is their paths will never cross, or they will never meet. They will never be in the same place. All right. Last one. Shipment of TVs weighing 30 pounds and 50 pounds is a total of 880 pounds. If there are 20 TVs altogether, how many of each type of TV are there? I'm going to label some variables here. I'm going to say that X are the 30-pound TVs, and Y is the 50-pound TVs. So now I need to write some equations. This first one, I have 30 times every X plus 50 times every Y is equal to a total of 880 pounds. So this is like the pounds. Okay, and then the other one is just the number of TVs. That one is just going to be X plus Y equals 20. There's my system. X's, Y's, equal signs, constants. I'm good. Now I need to multiply to make opposite coefficients. I'm going to take this bottom equation and I'm going to multiply by negative 30 because that's going to give me a positive 30, cancels the X terms. So the top equation stays the same. Bottom equation looks like negative 30x minus 30y is equal to negative 600. And add them up. X terms go away. I have 20y is equal to 280. Divide by 20, and I get y is equal to 14. I'm going to plug it into this bottom one because that equation just looks a lot easier. So I have x plus 14 is equal to 20. Really, I'm just taking 20 and subtracting the 14. So if I know 14 of them are 50-pound TVs, then I know 6 of them are 30-pound TVs. And that's exactly how I'm going to write it. 6 30-pound TVs and 14 50-pound TVs. All right. There we have it. So thanks for listening to the second half of this notes lesson. Don't forget to check off your notes sheet with Miss Johnson, and I will see y'all later.